Good day everyone! Welcome back to General Mathematics. It is still me, Engineer Umengan, to teach you logarithmic functions. Welcome to Logarithmic Functions, LBV Math 1-5.7. In this topic, our most essential learning competency solves a problem involving logarithmic functions, equations, and inequalities. The topic covered in this video: real-life problems involving logarithmic functions. For our learning objectives, by the end of this video, we want to solve real-life problems involving logarithmic function. Now let's go to problems involving exponential function. There's no better way to learn this than to solve problems. So, let's solve some problems. Problem number 37, the number of ants in a nest doubles every month. If there are now 600 ants, about how long will it take for their numbers to grow to 9,600? Let's remember that the general formula for exponential functions is y equals a times 1 plus r raised to t, and exponential functions and logarithmic functions are related, where a is the initial amount, r is the growth rate or rate of decay in decimal, t is the number of time intervals, and y is the future amount. Based on our problem, the initial amount is 600 ants, and the growth rate is double, so the growth will be 100%, or in decimal that is 1, and the future amount is 9,600. Since we are solving for the time t, we let y equals a times 1 plus r raised to t. We divide both sides by a, cancel a, and that will give us y over a equals 1 plus r raised to t. Now, we take the logarithm both sides. Logarithm of y over a equals logarithm of 1 plus r raised to t. Remember that we can use any logarithm with any base. We can also use ln in this case. However, it is, for example, we use logarithm with base 10. So from logarithm of y over a equals logarithm of 1 plus r raised to t, using this property of logarithm where logarithm of x raised to n to the base a, that is equal to n times the logarithm of x to the base a. So applying this to the right side of our equation, that will give us the logarithm of the quantity 1 plus r raised to t, that will become t times the logarithm of 1 plus r. So, we will have log of y over a equals t times log of 1 plus r. But since we are solving for t, we divide both sides by log of 1 plus r. Therefore, giving us t equals log of y over a all over log of 1 plus r. Substituting our values, our y is our future amount, which is 9,600, and our initial amount is 600. We will have logarithm of 9,600 over 600 all over logarithm of 1 plus r, and our r is our growth rate, which is 100%, or in decimal that is 1, giving us log of 1 plus 1 equals t. Typing this to our calculators, this will give us t equals 4 months. Problem number 38. A certain town has a population of 16,400 in 1990 and 20,200 in 2000. When will the population in 1990 be doubled? So again, we will start with the general formula for exponential functions, and then we will work our way to get to the logarithmic functions. That is, y equals a times 1 plus r raised to t. Again, where A is the initial amount, R is the growth rate or rate of decay in decimal, Y is the future amount, and T is the number of time intervals. Our initial amount is 16,400. Our future amount is 20,200. And the number of intervals is from 2000 to 1990, and that is 10 years. Solving for rate R, so 20,200 equals 16,400 times 1 plus R raised to 10. We will divide both sides by 16,400, and that will give us 20,200 over 16,400 equals 1 plus R raised to 10. Taking the 10th root both sides, that will give us the 10th root of 20,200 over 16,400 equals 1 plus R. Therefore, R equals 10th root of 20,200 over 16,400 minus 1. And that is equal to 0.0211. Now that we have our value of R, we can proceed to our general formula. So R equals 0.0211. And our future amount, since the question is asking for the year or when will the population in 1990 be doubled, so the population will be 2A. So that will be 2A equals A times 1 plus R raised to T. We divide both sides by A, and that will give us 2 equals 1 plus 0.0211. But since we are solving for T, we take the ln both sides. So we have ln of 2 equals ln of 1 plus 0.0211 raised to T. By applying this property, if we have log of x raised to n with the base a, that is equal to n times the logarithm of x to the base a. Applying this to the right side of the equation, we will have ln of 2 equals t times ln of 1 plus 0.0211. So, solving for t, we divide both sides by ln of 1 plus 0.0211, giving us t equals ln of 2 over ln of 1 plus 0.0211. And that is approximately 33.20 years. However, the question is asking for the year, so we will add 1990 to our year, thus giving us approximately year 2023. The population will double on the year 2023. Problem number 39. In determining the magnitude of an earthquake, the following concept is applied. If an earthquake has a shockwave T times greater than the smallest shockwave, which can be measured on a seismograph, then the magnitude M of the earthquake, as measured in the Richter scale, is computed by the formula M equals log of T to the base 10. The size of the shockwave is its amplitude, and the amplitude is half the difference between its highest and lowest points. Using this, if an earthquake has a magnitude of 4 in the Richter scale, what is the size of the shockwave? We are given the general formula M equals log of T to the base 10, where M is the magnitude and T is the number of times greater than the smallest shockwave. Our magnitude, based on the problem, is 4, and then we are solving for T. So 4 equals log of T to the base 10. This is in logarithmic form, which is log of x to the base a equals b, and we need to transform it to exponential form, which is a raised to b equals x. So from log of t to the base 10 equals 4, it will become 10 raised to 4 equals t. Thus, t equals 10 raised to 4 or 10,000 times the smallest amplitude of the shock wave. Problem number 40. How many years will it take an investment of 25,000 pesos to double in value if interest is compounded quarterly at a rate of 10%? Hint, A equals P times 1 plus R over N raised to NT. Again, this is our general formula. A equals P times the quantity 1 plus R over N raised to NT, where A is the future amount, P is the present amount, R is the growth rate or rate of decay in decimal, N is the compounding period constant, and T is the number of compounding years. Our future amount is double the 25,000, that is 50,000. Our present amount is 25,000. Our growth rate is 10% or 0.1. And our compounding period constant is equal to 4. Because based on our problem, the money is compounded quarterly. And in 1 year, we have 4 quarters. So solving for time t, we divide both sides by p. So we have A over P equals 1 plus R over N raised to NT. So taking the ln both sides, we have ln of A over P equals ln of 1 plus R over N raised to NT. But using this property of logarithm, if we have log of x raised to n with base A, that is equal to n times log of x with base A. So, we will have ln of A over P equals NT times ln of 1 plus R over N. So, since we are solving for T, we divide both sides by N ln of 1 plus R over N. And that will give us T equals ln of A over P all over N times ln of 1 plus R over N. So let's substitute our values. We have ln of 50,000 over 25,000 all over 4 times ln of 1 plus 0.1 all over 4. Typing this to our calculators, that will give us approximately 7 years. Problem number 41. Using the Richter scale, the magnitude R of an earthquake of intensity I is given by R equals log of I over I sub O for certain minimum intensity I sub O. Find R assuming the intensity of an earthquake is 1,331 I sub O. So since we are solving for R, we will just substitute our values. So we will have I equals 1,331 I sub O. So from there, we will have R equals logarithm of 1,331 I sub O all over I sub O. So we cancel I sub O. So simply, we have R equals log of 1,331. And that is R equals 3. And that's the end of our lecture. What we learned, we solved real-life problems involving logarithmic functions. In our next video, we will learn the basic of business mathematics. For supplementary problems, you may refer to QuexBook General Mathematics Chapter 3.